Welcome to Chapter 8 on water and minerals. So this is a great picture, and the book talks about water of the earth and the first seas, and that's where life originally appeared. The oceans are not just plain water, but a mixture of complex minerals, organic compounds, and water. And we know that over time, simple organisms developed to greater complexity, and many left a mineral-rich marine environment behind. And we know to survive, life needed to bring water with them in a similar internal environment. And we know that within our bodies, they're mostly made up of water. We have minerals in our body and our own internal sea, and this allows the chemistry of life to function. It's important to get the right amounts of minerals in water, and it's essential for survival. We do know that inadequate or excessive intakes of certain minerals are world health problems, and they can contribute to conditions like high blood pressure, bone fractures, anemia, and an increased risk of infections. We also know that getting enough clean, fresh water may prove to be an even greater challenge to human survival than meeting our mineral needs. Pollution and population growth are making fresh water an increasingly rare commodity. And we know that approximately 1 in 8 people around the world lacks access to a safe water supply. Though in the United States, clean water is accessible to most, there are huge aquifers beneath the surface of the earth, and we know that those are diminishing. And the water crisis may make shrinking oil supplies seem like a minor inconvenience for the simple reason that without water we would die. So water in the body. We're going to talk about water distribution in the body, the role of the kidneys in regulating the amount of water in the body, the functions of water in the body, and factors that increase water needs. Very often people don't look at water as an essential nutrient, but we know that if we lack sufficient water in the body, that it causes deficiency symptoms more rapidly than does any deficiency of any other nutrient. And we know that these symptoms can be alleviated almost rapidly as quickly as they appeared by drinking enough water to restore the body's balance. Water in the body, in adults, water accounts for about 60% of body weight, and water is found in different proportions in different tissues. We know that, for example, about 75% of muscle weight is water, whereas only about 25% of weight of bone is due to water. So muscles have a lot more water than bone. And we know that water is found both inside cells, intracellular, and outside cells, extracellularly in the blood, the lymph, and the spaces between the cells. We know the cell membranes that separate the intracellular and extracellular spaces are not watertight, and water can pass right through them. We also know that the distribution of water between these various intra and extracellular spaces depends on differences in the concentrations of dissolved substances. Cell membranes are permeable to water, so water can cross these membranes by osmosis due to diluted dissolved solutes. We know that blood pressure, water is also moved by the blood pressure, which forces water from the capillary blood vessels into the spaces between the cells of the surrounding tissues, and that body regulation or that our body regulates the amounts of water in cells and in different extracellular spaces by adjusting the concentration of dissolved particles and relying on osmosis for the movement of water. So here's a diagram that talks about water distribution. And so we know about 2/3 of the water in our body is intracellular or located inside the cells, and the other 1/3 is extracellular, located outside the cells. And the extracellular portion includes the water in the blood and lymph, and the water between the cells, and the water in the digestive tract, eyes, joints, and the spinal cord. And the distribution of water between the intracellular and extracellular spaces is affected by blood pressure and the forces generated by osmosis. So what is water balance? Well, the amount of water in the body remains relatively constant over time, and because we know water cannot be stored in the body, water intake and output must be balanced to maintain the right amount. So most of the water we consume comes from water and other liquids that we drink. Solid foods can also provide water. Most fruits and vegetables are over 80% water, and even like a roast beef is about 50% water. A small amount of water is also produced in the body as a byproduct of our metabolic reactions, and we lose water from our bodies in urine and feces through evaporation from the lungs and skin and in sweating. The amount of water lost in the urine varies with water intake and the amount of waste that needs to be excreted in the urine. In a healthy person, usually the amount of water lost in feces is small, usually less than about a half a cup a day. So to maintain water balance, intake from food, drink, and water produced by metabolism must equal water output from evaporation, sweat, urine, and feces. In this picture, it illustrates the approximate amounts of water that enter and leave the body daily in a typical woman who is in water balance. Increases in temperature or activity increase evaporation losses. So if losses from evaporation and sweat remain constant, increasing water consumption proportionally increases urinary excretion. So how is water stimulation managed? So the sensation of thirst motivates fluid intake in order to store water balance. So the need to consume water is signaled by the sensation of thirst. Thirst is caused by dryness in the mouth as well by signals from the brain. And it's a powerful urge, but often lags behind the need for water. So usually we need water before we're thirsty. And so we don't or can't always drink when we're thirsty. Therefore, thirst alone cannot be relied on to maintain water balance. How are the kidneys involved in regulating water loss? Well, to maintain water balance, the kidneys regulate water loss in urine. The kidneys typically produce 1 to 2 liters or 48 cups of urine per day, but urine production varies depending on the amount of water we consume and the amount of waste that needs to be excreted. So we know the kidneys also function like a filter. So as blood flows through them, water molecules and other small molecules move through the filter and out of the blood. White blood cells and large molecules are retained in the blood, and some of the water and other molecules that are filtered out are reabsorbed into the blood, and the rest are excreted into the urine. So what is the ADH, or Antidiuretic Hormone? This is important to know, especially for those of you going into healthcare, is that the amount of water that is reabsorbed into the blood rather than excreted in the urine, we know depends on conditions in the body. So when the solute concentration in the blood is high, as it would be for someone who has exercised strenuously or not consumed enough water. A hormone called ADH, or Antidiuretic Hormone, signals the kidneys to reabsorb water, reducing the amount lost in urine. And this reabsorbed water is returned to the blood, maintaining body water and preventing the concentration of dissolved particles from increasing further. And when the solute concentration in the blood is low, as it might be after someone has guzzled several glasses of water, ADH level decreases, and with less ADH, the kidneys reabsorb less water and more water is excreted in the urine, allowing the solute concentration in the blood to increase to its normal level. So the amount of sodium in the blood volume, and blood pressure also play a role in regulating all of this. So here's a diagram that helps kind of visually explain how the kidneys help to regulate water balance by adjusting the amount of water lost in the urine in response to the release of antidiuretic hormone. So now that we know about water balance, what are the functions of water? There are 5 functions of water in the body. We know that it's a medium for a participant in metabolic reactions. We know it helps regulate acid-base balance and transport nutrients and waste. And it provides protection and regulates body temperature. And this sure seems like a great multiple choice question, but water doesn't give us energy. You have to remember that. It doesn't give us any calories, but it is essential to life, and water in the body serves as a medium for and participant in all these metabolic reactions and all of the processes that are going on here. We know that hot weather and strenuous activity increases blood flow to the surfaces of the body. Shunting blood to the skin allows heat to be transferred from the blood to the surroundings, and evaporation of sweat cools the skin and the blood near the surface of the skin. Water is important in health and disease. We know without food you could probably survive for about 8 weeks, but without water you would last only a few days. And we know that too much water can also be a problem if it changes the osmotic balance, disrupting the distribution of water within the body. So what is dehydration? It's a state that occurs when not enough water is present to meet the body needs, and it causes a reduction in blood volume, and it impairs our ability to deliver oxygen and nutrients to cells and remove waste products. And we know that symptoms can be thirst, but headache, fatigue, loss of appetite, dry eyes, dry mouth, dark colored urine. So how do you tell if you're well hydrated? We know that your urine color is an indication of whether you're drinking enough. We know that pale yellow urine indicates you're well hydrated, and the darker urine, the greater the level of dehydration. And we know that rehydration saves lives. Dehydration due to diarrhea is a major cause of child death in the developing world, and replacing fluids and electrolytes in the right combination can save lives. And in some cases, oral rehydration therapy is sufficient, and that's often drinking mixtures made by simply dissolving a large pinch of salt and a fistful of sugar and a liter of clean water. And we know that can restore the body's water balance by promoting the absorption of water and sodium. And in severe cases of diarrhea, administration of intravenous fluids, as seen in this hospital in Bangladesh, is needed to restore dehydration. There is such a thing as called water intoxication, and that's when our water intake is greater than water loss, and the sodium in our blood is diluted, causing hyponatremia. Hypo means low, sodium is the chemical symbol for sodium, and emia means in the blood, and water moves by osmosis from the blood into the tissues to try to dilute the higher concentration of solutes, causing tissue swelling or edema. I'll stop here and then we'll go on to meeting our water needs.